let me shortcut this since I accidentally already recorded part of it and forgot to, so I'm going back. Shortcut. Here we go. You don't need to know really what this word Bernoulli trials, but these are the qualities for this chapter. I'm like I'm talking to you just because that's natural. Okay, so you have to have a success or a failure. You have to have independent trials. One trial is not changing the probability of the next. And the probability of success, like the probability of getting a green light from day to day, is the same, stays the same from day to day. So those three things have to happen this chapter. Next, the difference between a binomial distribution and geometric. So this vocabulary is important this chapter. The geometric ones we've already done, so I'm going to go ahead and re-talk about that. With a geometric distribution, you have a specifically defined order. For example, what's the probability that you don't get a green light, until Thursday? Say, you start on Monday, what's the probability that you don't get a green light until Thursday? Until is a common word that you're going to use with these geometric distributions, and so that is a specific order because it would go red for Monday, red for Tuesday, red for Wednesday, and then green on Thursday. So you would have those probabilities in that specific order. All right, whereas a binomial has a set number of trials, and we're going to call that letter N, and you want to know exactly a certain number of successes. For example, what's the probability that you get a green light, exactly twice this week? Okay. So what that means is, in this example, the number of trials is 5, because that's how many times we'll say that you come to school this week. The number of successes would be how many? Exactly 2. Now here's the deal. Can those two numbers, or those two successes, are they in a specific place? Are they in a specific place? Are they told to me to be in a specific place this week, just like this one was? Are they told to me to be in a specific place? Correct. Over here on this example, they are not told to me to be in a specific place. So therefore, the two successes can be mixed and in different combinations. That's what's making this binomial, because we can have a bunch of different combinations, as opposed to geometric, which has to be in a specific place. Okay? All right. So let's go with this example here. We're going to use this one actually quite a bit for the rest of the class. So let's kind of hone in on this problem right here. Okay. Let's say going home from work every day, so between 5 and 7 p.m., Berkshire's gets pretty crowded because you kind of got people coming home, and 25% of those people going in there, maybe you're just picking up a few things for dinner that night, and so 25% use the express checkout. All right, so peg that into your brain. The probability of using the express checkout from 5 to 7 p.m. on a weeknight is 25%. All right. Consider 5 randomly selected customers and let X denote those among the 5 who use the express checkout. So here comes 2 different kinds of problems. Here we go. Find the probability that the express checkout lane is not used until the 4th customer. So let's say you stood outside of Berkshire's on a weeknight from 5 to 7, and you wanted to get a correct sample, so you picked, say, every 10th customer starting in a random place. What kind of sampling would that be if you were picking every 10th customer? Systematic. Very good. Okay, so say you're picking every 10th customer. What's the probability that the first express checkout one you would get is the 4th one you asked? Okay, what's happening here? Is it defining the specific order, or do I have them like mixed up amongst the 5 I'm picking. It is a specific order. What's it going to look like? You know, geometric is shapes, and it's like visual. What's this situation going to look like specifically? The first customer is going to what? Not have done the express checkout. The second customer would have not done the express checkout. The third would have not, but the fourth did what? Use the express checkout. So what kind of problem was this? Geometric or binomial? Geometric, because it was a specific order. You could see exactly the order that was defined. All right, so how did our probabilities look on this? 0.75. That one and that one's not, and this one is not the express checkout, and this one is. All right, so then that comes out to be 0.105, and I want to know the interpretation of that. There's a 10.5% chance that what? That, okay. Good. Now, hint to you, you will pretty much be able to find the answer to the question in the question, the context in the question. It is right here. 10.5% chance that this right here, the express checkout is not used until the fourth customer. See? It's right there. So always go back to the question and find the answer of what you just found. So 10.5% chance that the express checkout is not used until the fourth customer. It's written right there. Okay, next. Find the probability that exactly 2 of the 5 customers use the express checkout. Okay? So is that going to be done differently? Exactly 2 of the 5 customers use the express checkout. What's different about this one? Yeah, those 2 could be sprinkled anywhere amongst the 5. Okay, do you see that? This is what you have as a binomial situation, because those 2 can be sprinkled anywhere amongst those 5. Now, the ultimate question comes in is how many combinations of those 5 can happen? How many combinations? Okay. Now, I want to take you through a couple of things here. So I'm about to take you kind of like on a little tangent for the next 5 minutes or whatever, and talk about this how many combinations idea, all right? And then this idea is just kind of for understanding. It doesn't end up being a way to do your problems in computation, okay? So here comes just a little like theory for a second. All right, here we go, real quick. Let's do that. Out of these 5, how might that work? You could have the express checkout occur where?
First and second.
Good. First and second. And then what? Yes.
First and third.
First and third.
First and fifth.
All right. Good. Rocking and rolling. Then what?
Second and third.
Second and fourth. Second and fifth. How about third and fifth? Because, well, now hold on. There's 2 missing here. Let me do the 2 left that are missing. Third and fourth. We're almost done. Third and fifth. And then the last one is fourth and fifth. Very good. So how many combinations occurred? 10 combinations happened. We placed those 2 express checkout people in 10 different locations. All right? They happened 10 different ways. What? Okay. Now, the 2 and the 5 thing appears to have a connection here, and it does not exactly. Okay, that's a coincidence in this case. All right. So here's what's happened. Let's go ahead and actually do this computation. If I was to find this probability, How do I do one of these? How do I actually compute this? 0.25 times 0.25 times 0.75, and there are 3 of those. So in every single one of these cases, I have 2 of the 0.25s, and I have 3 of the 0.75s. And how many of these combinations were there? 10 of them. So if you multiply that together, you get the answer 0.264. So in summary, there's a 26.4% chance that when I stand out there, chance, how about I change that right there? Whew. There's a 24.6% chance that when I stand out in front of Brookshire's, exactly 2 of the 5 customers use the express checkout. All right? 26.4% chance that 2 of the 5, exactly 2 of the 5 customers use the express checkout. What is the difficult thing here? What's the Woo! That was so good. Yes. That was really good. That was like almost Stanford because it has been a long day. Oh, almost. Okay. That is good because it's just been a long day. Okay, right. So this part right here is not hard. I know I was going to have 2 successes and 3 of them that are not express checkout. What's the hard thing to find out? How many combinations? Very good. So, turn the page and let's talk about how you could figure that out without writing all of this out. There is this little, I'm going to actually skip to this little part right here. There is this magical formula that could figure out the number of combinations for you without you actually writing them all out. And it looks like this. N, so that's the number of trials, choose exactly K successes. Okay, so N is the number of trials, K is the number of successes. Okay, so let's do our problem and see how that works out. In our problem, we had 5 trials, and we want to know the combinations of 2 successes. Okay, 5 and the combinations of 2 successes. Now, according to this little thing right here, it says you can notate this a 5 on top of a little 2. No fraction line. A 5 on top of a little 2. No fraction line means 5 trials, exactly 2 successes. Now, according to this little formula right here, it says n factorial. That exclamation point in math is factorial, which we're going to talk in a second, on top of k successes and n minus k, which is the number of failures. So let's do that here. All right, so I've got this. What's the number of trials? 5, and we're going to write that as a factorial. What's the number of successes? 2 factorial, which would then mean how many number of failures? 3 factorial. Okay? All right, so guess what? What does this factorial thing mean?
5 times 4 times 3.
Good. This factorial thing means 5 times 4 times 3 times 2 times 1. It does not mean, woo, 5 or like 2. Okay? It does not mean I'm really excited about the number 5 or the number 2. Okay? It means 5 times 4 times 3 times 2 times 1 over 2 factorial would be 2 times 1, and 3 factorial would be the 3 times 2 times 1. Well, guess what? The cool thing is one of them always cancels. So this 3 times 2 times 1, they cancel. And what do I end up with? 20 divided by 2, which is, how much? It's magic. It is 10. And where have you seen that before? Oh my gosh. Right here. 10 combinations that we had to do by hand, okay? Now, of course, there is a place for this in your calculator. You don't have to memorize this, so just watch, because there's like, you don't really even have to use this, but I have to walk you through it. If you go math over to probability, where do you see this? Right here in choose R successes. They call it R. All right, so watch how this would work out. 5, and then I go math over to probability, choose 2 successes, and that is 10. All right, now, me being the nerd that I am, this is like actually really fun for me to do, and I remember that in high school when calculators didn't do all this work for you, you had to in my high school, okay, whenever it was way back in the day before these TI calculators, we had to compute this by hand. So let's do this, okay? Let's do another one. You ready? Let's do, out of 10 trials, let's do a bunch of trials. Out of 10 trials, I want you to have 4 successes. Okay, so that would be like 10, choose 4. What would that look like in the formula? 10 factorial on top of what? 4 factorial times 6 factorial. So this would be like 10 times 9 times 8 times 7 times 6 factorial. Why do I not have to go any further? Because I got 6 factorial on the bottom. That's going to cancel. So on the other part is 4 times 3 times 2 times 1. Now, let's please reduce. How about the 4 and the 2 equal the 8, so that's gone. What else can I reduce? The 3 reduces and the 9 becomes a 3. So essentially, on top, I've got 10 times 3 times 7, which is 30 times 7, which is, or 10 times 21. How much is that? 2, 10. So there's 210 combinations that, thankfully, I don't have to figure out by hand, okay? Woo, I know. And so just real quick, for you to see this, 10, math over to probability, choose 4 combinations, boom, 210. All right, so I know you are so excited. So this is all done to replace this thing in choose K. In successes, in trials with K successes comes out to be whatever number it is that we just computed. All right, and then look at this part of the formula. P to the K. Okay, P to the K. That is the probability of success and how many successes you want. This part right here is the probability of failing and how many failures you want. So this section is all about the failures. Okay? So let's finish this thing out. Let's show you that if I had to show the work for the problem on the front with this formula, because that's the way to do it, is you would go like this. The probability of having exactly 2 successes, okay, we're talking 5 people coming out of this Brookshires, 2 of them went through the what? Express checkout line. Okay. So it would look like this. 5 people coming out of Brookshire's. Exactly 2 of them did the express checkout line. And what's the probability of success? Is it not a 25% chance of going through the express checkout line? Okay. And how many do I want to do that? 2. What's the failure portion? Not going through it. And how many do that in this case? 3. Okay. So this is the work that gets shown. And then let me show you how you can do this whole thing in your calculator without even having to do this combination stuff in your calculator. You don't even have to do that. But I'll have to tell you, so I'm pretty much done with the end of the little tangent. This right here, you have to know this stuff. You got to kind of know that you got the n successes, and then you got the successes factorial and the failures. Thank you. Because, so you actually really have to know that, because that could be a multiple choice question where they ask you about the combinations, and you have to like be able to show them this, okay, that you know how to compute the number of combinations, okay? So that's why I kind of did this little tangent. But the shortest way possible, if this was a free response question, would be go show the work, which this formula comes from your formula chart. Where is it found on the formula chart? Do you see it? It's magically right here, okay? So just show the work with that, and then here's how you do it in the calculator. Okay? Now, hold on a second. Ready? On your formula chart, again, here is the work that you have to show, but then the cool thing is, I'm going to tell you how to do this thing in your calculator without even really having to do any of this stuff by hand, and here's how that looks. Okay, you ready? Okay, in your calculator, there's this thing that is binomial, okay? P, because you want particularly, exactly 2 successes, okay? So in your calculator, it'll go like binomial PDF, and you want the number of successes, so, I mean, the number of trials, okay, comma, the probability of success, so this is like the shortcut to doing this whole thing in your calculator without having to do it by hand, comma, K, and what does K stand for? The number of successes, like how many you want to find. So in our Brookshire's problem, I mean, seriously, like, okay, in our Brookshire's problem here, okay, yeah, I don't know what's going on, but here, in our Brookshire's problem, we will actually put into our calculator binomial PDF. I'm about to show you where that shows up. How many trials did we have? How many people were we looking at in Brookshire's? Actually, we were looking at 5, thank you. What's the probability that somebody went through the express checkout line? Okay, 0.25. And then how many of those people did I ask you to find? Exactly 2 of them. Okay, so here it comes in your calculator. Okay, you ready? So, open that calculator up. It is right here. You ready? You find it second bars. It's black there where the norm CDF is and all that kind of stuff. But you actually have to do the binomial distribution, not the normal distribution. So it's actually pretty far down at the bottom of the list. But the quicker way to find it is actually to go up. And here we go. Look, binomial PDF. It's P because it's in particular. Okay? Exactly 2 successes. Okay. I know. So here we go. Out of 5, comma, the probability of success is 0.25, comma, how many successes? Oh, that's I'm sorry, 0.25 is the probability of success. Okay, and then how many do I want? How many successes do I want? 2. Okay. Now, what did we say over here on this page was the answer when we did this like all by hand? 0.264. So, oh my gosh, you're about to be excited. Boom. 0.264. Okay. So, in summary, you technically do not have to go through all of this stuff here to find out that there's 10 combinations. You also technically do not have to go through all of this stuff here, okay, to find out that there is 10 combinations. The shortest way to do this is to show your work this way with the formula and then go put it into your calculator. Voila. And there's your answer. Okay? So, let's do one more problem. So, the answer is 0.264, which is 26.4% chance that if you ask 5 people coming out of Brookshire's, what?
2 of them.
Exactly 2 of them. Okay, 2 amongst those 5. Okay, now look, I have another question for you right here. It's this one right that says number 5. But what if our grocery store problem, same one, said what's the probability that at least 4 of them, 4 of the 5, use the express checkout link? Okay? So, how can I do that with what we learned? At least 4 would mean like exactly what? Plus exactly 5, because we're just asking like out of 5 people. Okay, so really, in particular, I want to know the probability of getting exactly 4 plus the probability of getting exactly 5. So, on the AP test, you would have to show your work by doing this for 4 plus, actually, this right here for what? 5. Okay? Can you do that right now? I want to go ahead and walk around and see you do this for 4 and this. Here's the 4 success part. Okay, so here's how you show work. For the out of 5, you have 4 successes. 4 that went through the express checkout. So that's 0.25 to the 4th times 0.75, because how many do not go through the express checkout? 1. Okay, good. All right. So how would this other part look? The 5 successes, how would that look?
5 of 5.
Yeah, 5, choose 5. You don't write it with a fraction. Don't write it with a fraction line. It's 5, choose 5. So how many successes? So it's 0.25 to the 5th power. And then how many failures? 0. Okay, so that's the work that you show. And then, so again,
Do you have to put 0.75 to the 0?
it's kind of like just the part of showing your work, but you don't actually compute. I mean, right, because what does 0.75 to the 0 actually mean? Right. So here's how this would look in your calculator. Oh, I forgot to tell you that if you have Stat Wizard, did you notice that
It's on
if you have Stat Wizard, then what will happen is when you do this in your calculator, it comes up and it asks you, when you do this in your calculator, what does it say right there if you have Stat Wizard? Number of trials. How many trials are there in this case? 5, good, comma, what's the probability, and then the next thing is probability of success, which is 0.25, and then the next thing is how many successes, which in your calculator, if you have Stat Wizard, it says x equals, okay, and then that's your 4. All right, so that's the 4 one, and then what do? Plus, and then I'm doing the 5 one. So, binomial PDF, what? 5, comma, 0.25, comma, 5. All right, and that comes out to the answer, which is, meaning that there's a 1.5% chance, 1.56% chance that what?
at least 4 of the 5.
Yeah. Good. At least 4 of the 5 use the express checkout. Good. Now, I want you to come down here and do this number 6 real quickly. I do not like C and D. I'm mixing those. I will tell you that 2 of these are geometric, like the old stuff, and one of them is binomial. So I want to give you a moment to do that. I'm going to tell you the answers so you can kind of check yourself and see if you did these right. And then I'll show you the work shortly. The answer for this one is going to end up being 7.91%. This B is 1.17%, so you can kind of check yourself. This one down here will be 25%. So work on those for a second, and then I'll come around and kind of help you, well, and then give you some help there.
Bless you.
So this first one defines an order. That's what's making it geometric. So, this one wears a seatbelt. Wears a seatbelt. The first 5 wear their seatbelt. That's wrong. The first 4 wear the seatbelt. It's the 5th one that does not. So these 4s are 0.75s. Okay? The next one, the first 4 are 0.75. This one here is similar. This one here is similar, that it's about the 4th car. So it defines the order. It says the 4th one is the first one that is wearing a seatbelt. So it's this here, and then your 0.25s for the rest. Now, real quickly, the last one is one of the binomial problems because you have exactly 3 out of the 10. And then so that I don't run out of time before you guys have to leave. Your homework is these problems here. Chapter 17 homework, part 1, where it says day 1 on them. The problems that say day 1 on them. Okay? I hand wrote that on the packet, on the problems, all right?
Hey, what state's the Garden State?
New Jersey. Thank you. All right, I didn't get to finish this one, so let me do that real quick. This one's 10, choose 3. The 3 without a seatbelt is the 0.25, and there are 3 of those. And with the seatbelt, there would be 7 of those.